Good morning, everyone. Thank you for joining me for Chapter 1 and the very first lesson for sixth grade math. Today, really what we're going to be doing is a lot of reviewing from probably last year. So, Section 1 is titled Whole Number Operations. This is kind of a review. Hopefully, most of it's a review to you. Those whole number operations would be like adding, subtracting, multiplying, and dividing. Chapter 1 is numerical expressions and factors. Please also don't forget to include your name and date. And added my little Bitmoji this morning because, boy, after the time that we've had off here this last summer, time to get those brains warmed up. So we have a warm up here, but don't forget to also include your learning target, which for today is I can determine which operation to use when solving real life problems. So looking at a real life problem, thinking, do I need to use addition or subtraction or whatever it might be? Okay, so why don't you take a second here to look at our magic square, our warm-up problem of the day. And the magic square is right here. If you want to draw your own, you can, so that you don't have these question marks in here. But it says in a magic square, the sum of the numbers in each row, each column, and each diagonal is the same. The sum of the numbers. Okay, that's an important word. Is the same in each row, column, and diagonal. Right? Each number from 1 to 9 is used only once. All right, so these numbers that are already in there can't be used again. Complete the magic square. So you need to find these 5 missing numbers here and then explain how you found the missing numbers. So maybe if I were you, I'd think about drawing my own magic square over here and putting in the numbers that are already in there and then seeing if you can figure out what numbers go in the missing boxes and then explain how in the world you figured that out. Why don't you pause the video now to think about it, try it out, and reread the directions if you need to. All right, hopefully you've had the chance to try this. Maybe it's frustrated you, maybe you got it right away. I'm not sure, but let me kind of explain my method. I know that my sum, so that means when I add the numbers in each row, column, or diagonal, that number is the same. Well, I'm going to use this little piece of information. I already know what that magic number needs to be because 8, 5, and 2 are in a diagonal. And all 3 numbers there, when I add them up, should give me that magic number, if you will. So 8 and 2 would give me 10, plus 5 would give me 15. So that means that in every diagonal I need to have 15, every row I need to have 15, and every column I need to have 15. Right? So now let's go to a row that has 2 already for me. So if I look at this top row here, I have 9, 10, 11. What am I missing to get to my magic number 15? Well, that would be 4. I have 2 here, so 8 and 4 is 12. What am I missing to get to 15? That would be 3. Yeah. What else do I have? All right, now I have these 2. So 3 and 5 is 8. How many more do I need to get to 15? I need 7. All right, I have this diagonal right here. 4 and 5 is 9. I need 6 more to get to 15. And I have 8 and 6 is 14. 1 more to get to 15. Does that hold true here? Yep, 9 and 1 is 10, plus 5 is 15. So now every which way I add up to 15. Okay? So that's kind of the way I tackled that. And the big key here is that I recognize this word sum means to add. So when all my numbers are added up, I should get the same magic number of 15. All right, hopefully that got you thinking and got you warmed up. Let's start with a reminder for today. Your reminder is recall that the four basic operations are addition, subtraction, multiplication, and division. You might also see some different words that represent those operations sometimes, like the word sum is often used to describe the operation of addition. You might see that in a word problem. Or difference talks about subtraction. Over in the last chart here, you'll see that they give an algebraic example. So they just swapped in letters for numbers. So A plus B. Difference means subtract, so A minus B. Product of is kind of a tricky one, but a good one to kind of know, means to multiply. And I will point out one thing here too. A lot of times in 6th grade now, you'll start seeing the dot used for multiplication instead of the X like normal. And the reason behind that is because when we get actually into a little bit of algebra, we might use the letter X. And if we have to use the letter X and the symbol multiplying, that looks really weird, right? Yeah, you don't know if it's an X, the letter, or the symbol multiply. It gets really confusing. So we instead use the little dot. And lastly, of course, we can't forget about division, which a lot of times in word problems you see the keyword, the quotient of. You'll also notice that division can be written quite a few different ways. Here's your classic division sign. Division can also be written as a fraction. Those are in fact the same thing, and we'll get lots of practice with that this year as well. And then also the long division bar that I'm sure you've seen probably in 4th and 5th grade. All right. So those are just good reminders. I might make a star by this because you can always come back and look at this in your notes. And it might be a good thing to check out again. Maybe if you're on a word problem and you don't really understand one of the key words, it might help you. So let's take a look at an example of what one of these problems might look like. It says the bar graph shows the attendance at a 3-day art festival. What is the total attendance for the art festival? All right. One thing I noticed right away is that I have this keyword of total, right? If I were to ask you what operation you would use to find out the total of something, what would you tell me? Hopefully you've arrived at addition. If I asked you the total number of students in this class, you would add the number of students in this class to get that answer. So what is the total attendance for the art festival? We are going to use addition, and we're going to look at the 3 days, and we're just going to simply add our 3 days. So I've got 2,570 plus 3,145 plus 3,876. I have the same number of digits in each of my numbers, so they line up real nice vertically there. Remember, you have to line up the numbers by their place values. So the total attendance, now I just add 0 and 5 is 5, plus 6 is 11, carry my 1. 1 and 7 is 8, plus 4 is 12, plus 7 is 9. Oh, that made a little circle there. It's going to erase. Let me do it quick. Okay, perfect. Moving on to my next row, I have 5 and 1 is 6, plus 8 would give me, what would that give you? 8 and 6? 14-ish? Oh, I must have did something wrong here. Let's recalculate. 8, 9, 10, 11, 12. Oh, I forgot to carry my 1 because I had 19. There we go. So now let's try 6, 7, 15. Carry my 1. Don't forget about that, Mr. Gillis. And lastly, 3, 6, 9. And 1, 2, 3, comma. I have a total of 9,591. And don't forget our label of people who attended the 3-day art festival. Pretty good showing of people. All right. Letter B then asks, what is the increase in attendance from day 1 to day 2? Okay, so here was day 2, and here was day 1. It wants to know how many people did we increase by. Okay, so in this case, the phrase how many more indicates that we need to find the difference in the number of people. So when we find the difference, remember that means, if you look back up here, we need to subtract. So let's take our number of people that we had on day 2, which was 3,145, and subtract that from our first day attendance, 2,570. All right, doing a little subtraction here. 5 minus 0 gives me 5. 4 minus 7, can't do, I'll borrow. This becomes a 0. This becomes a 1. 14 minus 7 will give me 7. 0 minus 5, I can't do, I need to borrow. This becomes a 2, this becomes a 10. 10 minus 5 is 5, and 2 minus 2, nothing. So the difference is 575 people. All right, hopefully that's a good review for you, but I think the biggest thing is using some of these key words here definitely helps you take a real life problem and figure out which operation to use. All right, let's move on to example 2, where we talk about multiplying whole numbers. It says a school lunch contains 12 chicken nuggets. Oh my gosh, I'm gonna get hungry already. 95 students buy the lunch. What's the total number of chicken nuggets served? Again, we're looking for total. So you may be thinking here, when you see the word total, oh, that means to add, right? Well, that would be one way you could do it. You could say student 1 gets 12 chicken nuggets, plus student 2 gets another 12 chicken nuggets, plus student 3 gets another 12 chicken nuggets. But imagine if you had to do that for 95 students, how incredibly painfully slow that would be. Just absolutely, that would take forever. That would take the whole hour. So we're not going to do that. A good reminder is that multiplication is the same as repeated addition. And that's what we're doing here. We're repeating 12. We're adding 12 each single time. So multiplication is the same thing as repeated addition. Instead of doing that, I'm just going to take the 12 chicken nuggets that each student gets and multiply that by the number of students I have, and that should give me my total. Because repeated addition is the same as multiplication. Okay? There are 95 groups of 12, in other words. Okay, so let's multiply here and see what we come up with. I'm just going to use our standard algorithm. So I'm going to take 5 times 2, which is 10, carry my 1, and 5 times 1 is 5, plus 1 is 6. Now remember, when I move to my next digit here, I need to add in a placeholder or a 0. And now I can multiply. I have 9 times 2, which is 18. Carry my 1. 9 times 1 is 9. Plus 1 is 10. Okay, and then I add these two. So 0, 6, and 8 is 14. Carry my 1. 1 plus 0 is 1, and 1 plus 1 is nothing. So I come up with a total of 1,140 chicken nuggets. And wow, that sounds like a lot of chicken nuggets, and now I'm hungry. All right, we are now to the on your own section. And for these sections, what I ask you to do is to pause the video and try these out on your own first, and then come back, unpause the video, and check to see if you got your answers right. All right, hopefully you arrived at these answers. If you didn't, and you want some help with it, please let me know and I'll be glad to do so. Adding these two, you should come up with 2,427. Number 2, you should come up with 113 when you subtract. And number 3, when you multiply, 4,956. If you need help on any of those, please feel free to ask me or rework those problems to see if you can get the right answer. Moving on to the third example, we're talking about dividing whole numbers with no remainder. So it says here you make 24 equal payments for a go-kart. When you make equal payments on something, you're dividing them equally. All right, so that's kind of a key word there. You pay a total of $840 for this go-kart. How much is each payment? Now, I can tell you guys it doesn't get much more real life than this. Maybe you never buy a go-kart, but what you probably will buy someday is a car or a truck. And most people can't just pay a total lump sum. New trucks these days are gripes, $50,000, $60,000. Nobody has that money laying around. So you have to make equal payments to your loan if you take out a loan, right? So this is extremely real life and extremely applicable to you. So we're trying to find out how much is each payment. In other words, how much do we pay, monthly if we're trying to figure out our budget of how much we make and if we can afford this, just like adults do in everyday life, #adulting. You got to figure out that budget to know if you can afford something. So let's try that. Let's see if we can take our total of $840 and divide that by our 24 equal payments to find out how much each payment will be. Probably monthly is my guess. All right. So the first thing I'm going to ask myself is, does 24 go into 8? And the answer will be no, because 24 is bigger than 8. So I need to go to my next digit. Does 24 go into 84? Okay, and yes, it does. And how many times now? Well, if I round this to 20, 20, 40, 60, 80, that's 4 times. But since it's bigger than 20, I don't think it's going to quite go in 4 times. So I'm going to try 3. Notice how I put the 3 right above the 4 because we're trying to figure out how many times it goes into 84. Right? And if you need to do a little bit of, side bubble work here, feel free to do that, to check. What is 24 times 3? Okay, 4 times 3 is 12. Carry my 1, 6, 7, 72. That's good because we couldn't fit another 24 into here without that. Okay, so now we subtract. 4 minus 2 is 2. 8 minus 7 is 1. And then lastly, I bring down my 0 here. And then I ask myself, how many times does 24 go into 120? If I were to round this to 25, I'm going to be thinking about quarters because quarters are 25 cents. So 25 cents, 50 cents, 75 cents, $1. That's 4 quarters. I could probably do one more and I'd get to $1.25, which would be close to $1.20. So let's try 5 and see what we come up with. 24 times 5, 20, carry my 2, 10, plus 2 is 12. Perfect. That's 120. 5 times 24 is 120, and I have no remainder. All right. So how much is each payment? Each payment is $35. Notice how I boxed my answer to kind of make it pop. I hope that you start doing that in some of your homework practice too, so you can easily find that. All right. We're to another section of On Your Owns. You might hear me refer to these as oyos on your owns, oyos. So it says find the value of the expression and use estimation to check your answer. You can just do this using mental math. You don't have to write this down necessarily, just double check. Okay. So again, please pause here for the on your own section. And in a minute, I will reveal the answers, but it's of your best interest to pause and try it out first by yourself to see if you are catching on. All right, number 4, you should get 26. Number 5, you should come up with 17. Number 6, 8. And number 7, 31. Okay. Again, please feel free to ask me if you didn't get those, or even check with a friend or a neighbor and ask how they got those answers if you didn't quite get that right. All right, we are to the last example here, the real life application. If you feel like this lesson has been dragging on, I'm sorry. Feel free to pause and stand up and stretch or whatever you need to do here to get re-energized for the last problem. All right, let's tackle it. It says a 301-foot high swing at an amusement park can take 64 people on each ride. Okay. A total of 8,983 people ride the swing today. All the rides are full except for the last ride. How many rides are given and how many people are on the last ride? Okay. Wow. It's kind of a wordy problem. First thing I would ask myself, is there anything in this problem that is extra information that I don't need to know, that maybe the book is just trying to trick me? 301-foot high swing. Oh, this first piece of information. This doesn't even matter. It doesn't matter how tall the swing is. We're trying to find out how many rides are given. So don't even worry about that. I should actually not highlight that. I should almost just erase that, right? We don't need to know that. It's kind of cool. That's really high. I might be screaming like a little girl if I had to ride that. But we don't need to know that to solve this problem. So let's ignore that for now. We do need to know, I bet, the total number of people who ride. And each ride takes 64 people. Okay, so if I take my total number who ride the swing, which is 8,983, and I divide that by how many are on each ride, that should tell me how many rides are given. The catch is that I'm guessing there's going to be some type of a remainder because it says all of the rides are full except for the last ride. So there's not going to be an even number of 64 people on the last ride. So let's see first what we get when we find out how many people are on, or how many rides are given when we divide our total by the number of people who can ride each time. So 64 goes into, no, it doesn't go into 8. It goes into 89 one time, because 1 times 64 is 64, and we can't get another 64 in there or we'd be higher than 89. So 9 minus 4 would give me 5, and 8 minus 6 would give me 2, and I'll bring down my next number, which is 8. All right. If I estimate this to 60, how many times does 60 go into, let's estimate this to 200. So 60 would go into 260. Let's see. 60 times 2 would be 120. Another 60 would be 180. Another 60 would be, let's see, 240. So that's got to be close. So let's try 4 times. 64 times 4. 16, 24, 25. Ooh, that's really close. That's awesome. So 256. And if I subtract it, I'd get 2, and that's it. And bring down my 3. Okay. And now, how many times does 64 go into 23? Well, 0 times, because it's too big. So if I subtract, I still have that 23 left over. Now, if maybe at some point last year you went like this, remainder 23. And really this year we're going to start getting away from using the remainder or the big R sign. We're going to get more used to writing it as a fraction. So I have 140 whole rides and then I'm going to write my remainder, this 23, as a numerator. So, and 23 64ths. I'm just taking my number that I was dividing by here and writing that as my denominator. Okay. So the quotient, the answer to my division problem, is 140 and 23 64ths. Okay. So how many total rides are given then? Well, this represents 140 rides given that were full. There actually was one more ride, though, given, because only 23 people were on that ride and 64 could fit on it. So there was actually 141 rides given. And how many people were on the last ride? Well, it was just a partial. It wasn't a total 64. It was 23 people on the last ride. Okay, so that does it for example 4. All right, 8, 9, and 10 are all very similar to that last problem there, where we're dividing, and you are probably going to have some type of remainder. Okay, so pause the video for the OYO and see what you come up with. Alrighty, for number 8, you should come up with 203 and 1/5. Remember, don't write it as remainder 1. Okay, and if you can, simplify. So number 9 should come up with 1,631 and 23 28ths. And number 10, we have 7 and 41 86. Okay, these ones might be a little bit trickier, so definitely let me know if you have questions on those, or ask a friend or a neighbor or someone for help if you need. All right, that concludes lesson number 1, the very first lesson in chapter 1, and for your 6th grade year. Hopefully it's a review of these whole number operations. As always, please ask me for more help. I will be glad to help you, and I will see you next time.